So, ladies and gentlemen, coffee break is over. Unfortunately, we have come back to business. And I think for the final event of today, after hearing all these talks, now we would like to engage on a panel. You see the title of the panel already here on the screen, The Future of AI, even though I heard that a lot has been already talked about the future of AI, and you learned a lot of the future of AI in the previous talks, even though now we will go to some very specific questions. And it's a great pleasure for me to have 4 panelists who agreed to join this event. And let us call them on stage. So we start with Michael Bronstein. So you already know him from his talk before, but just to recall, he did his PhD in Technion in 2007. He has been at many institutions, had professorships. Currently is a Google DeepMind professor at Oxford. He's also at the AITHYRA Institute of the Austrian Academy of Sciences and also linked to Technical University and University of Vienna as an honorary professor. He has many distinctions and awards, and we don't have time to mention all of them. And he's very well known for his groundbreaking work in machine learning, in particular for his work on geometric machine learning. So welcome, Professor Bronstein. I would like to continue with Pascal von Hentenryck. So he's perhaps the most senior person here in the room regarding his PhD, because he did it in the 80s at the University of Namur. He spent years at the ECRC in Munich, so the elder people like me still have experienced this, and then moved to the US. He spent some time also in Australia and then went back to the US and is now at Georgia Tech. He also has many distinctions and awards, and he made pioneering advances in constraint programming and in stochastic optimization. So welcome to Professor van Hentenryck. Next, I would like to call Claudia Plant. So Claudia did a PhD in biomedical informatics at the University of Innsbruck, at the Medical University of Innsbruck there. She has been a visiting professor at Florida State University. She was leading a research group at Helmholtz Center Munich before she was joining University of Vienna in 2016. She also got many recognitions and awards, and she's working in data mining and machine learning. So welcome to Professor Plant. And last but not least, I would like to call Marta Sabou, who did her PhD at Freie Universität in Amsterdam in 2006. During her career, she was at different institutions, also at our institution for some time, where she was leading a research group. She also worked in industry at Siemens Company for some time before she joined the University of Economics, Vienna, where she's now the head of departments of information systems on operations management. Yeah, she's also an accomplished researcher, and for example, she had an FF Elise Richtergant for outstanding female researchers that she was carrying out at our university. And she's working on especially semantic web and human computation. So thank you very much for agreeing to be on this panel. And the plan for this discussion today is that we look at some questions, and I will first ask the panelists to comment on these questions before we engage then in a discussion among the panelists and then also the audience. So the first question, so to say, is just setting the context. So maybe we already, I see that some did not look up the questions to the panelists, which were sent before in advance, but I mean, they are not so difficult for them to answer. So where are we today, and what were key impacts that AI had on your research area and your own research? So in the last 5 years, and we would appreciate if you can just share your personal experience and opinion on this. And I would like to start with Professor Bronstein.
Good question. So, good question. I think if I were to say in one word where we are, I would say that everything that we see nowadays, not even 10 years ago, I would say 5 years ago, even to experts working in this field, would seem science fiction. So that's where we are now. And I'm especially talking about what we see in generative models. Let me just remind you with concrete examples, right? So take generation of images. So nowadays we have the most recent thing, it was dropped from Google, Nano Banana Pro or 2 or whatever it's called, generating incredible images with also very accurate control. So just 10 years ago, even less than 10 years ago, the best thing we had was guns, which could barely generate a realistically looking human face. And that was considered to be the kind of the top. So what has led us there is two things. So one is new models. So the story of deep learning so far has been scaling in data, in compute. And every time that people were saying we're running out of steam or running into the wall, somehow almost a new dimension where you can scale open. So initially it was the pre-training scaling, then post-training scaling. Nowadays we have also inference time scaling. So the model, roughly speaking, can think for longer after it has already been trained, right? And also combination with techniques about which we also heard today, like retrieval, augmented generation, and so on. But if you look at the algorithms themselves, so deep learning to a very large extent was just what Lecan calls differentiable programming. So basically systems, large systems with a lot of parameters trained by backpropagation. So mathematically, it is not exactly a very interesting thing to study. Nowadays, we have very different methods, right? So that have actually very deep and very interesting and very diverse mathematics that underpin them. So, and I'm talking about, for example, generative diffusion models that are fundamentally reliant on stochastic differential equations, or, for example, flow matching models, which are in their foundations are basically have deep geometric constructions. So it also allows probably to develop the methods themselves in a way more interesting way. So it's probably deeper theoretical scientific problem than just engineering. And I don't want to dismiss the just engineering. So it took a huge effort of very smart people to get us to where we are. But I would expect that we will see probably more progress from theory in the next years than just from scaling and more data and more compute and some kind of tweaking of these systems. So that's what we might take where we stand.
Okay, thank you very much. No? Maybe we can continue with Professor van Hentenryck. No?
Yeah, sure. Can you hear me? Yeah. Okay, good. So I think I'm a computer scientist by training, very old, as you said.
I'm not old.
And
experienced.
But I spent the last, 15 years in engineering schools. And when you work in an engineering schools, people ask you to actually solve engineering problems. And engineers have a very, very different relationship to things that they build compared to computer scientists. And I'm not making a judgment here, right? So they want reliability, they want scaling in the sense that they can apply that to real problems and so on. And so when you think about that, a lot of the work that we have been doing is actually saying, how can you apply concept from AI in a reliable way such that you do a step change in the set of problems that you can solve? And so what we did is essentially looking at all the engineering discipline one at a time, and obviously we haven't covered everything, but we look at every one of these engineering discipline and we say, can we solve these things in a way we couldn't do 5 years ago? You were talking about 5 years. And I think what we have shown, and this is obviously the baby steps, right? But there are a number of problems that we can solve now that we couldn't solve 5 years ago. And I think that's for me a big success of AI. The fact that you can combine AI with fundamental engineering tools in a reliable fashion such that people get comfortable in actually deploying them in practice. And so if you fly a plane, you probably want to have some reliability in the plane. If you file a power grid, you probably want the light 99.999% of the time. And so that has been the challenge. How do you combine AI with actually engineering disciplines such that you can do a step change in your abilities to solve problems? I'll stop there.
Okay, thank you very much. Now, Professor Plant.
So my answer is it's really remarkable how capable AI methods are. So when you look at the videos that are generated, so it's really that you often cannot tell if these are AI generated or human generated videos, also for images and texts. However, at the other side, when you have a specific application problem, and I have been working throughout my career a lot with neuroscientists and medical scientists, it still is a challenge to really make use of current AI methodology to, for instance, inside clinical practice. So when you have an Alzheimer's patient and the doctor must decide what kind of treatment is the best for this particular patient, okay, there is a lot of help and research is much accelerated through AI methodology. However, there are many complex questions we need to solve that do not follow the characteristics that we have an easy to measurable success characteristics, so like classification accuracy, but these are complex questions. So I must judge as a doctor what is the best solution for the patient, for the quality of life, for his joy of living, for the trade-off of the living time and the quality of life and things like that. And there it gets really into all possible sciences like social sciences, psychology. There are connection points to many of these other disciplines. And this is just an example about which I know a bit more in my career. I know that also similar examples exist in other applications like smart usage of energy. The question is also smart usage for whom? For the energy provider, for the customer? Is it to increase the reward in terms of money, or is it for the environment? Or often there are many stakeholders, and AI methods can help, but they cannot solve everything.
Good, thank you very much. And well, last but not least, Professor Sabou.
Thank you. So, good afternoon, everybody. It's so nice to see so many of you still here wanting to know more about AI. So before I can answer your question, Thomas, I want to give a little bit of insights into my background and what is my area of expertise, also because it has not been mentioned so much today in the talks that we had. So we had mostly talks from optimization, machine learning, life sciences, neuroscience, right? And my background is particularly from knowledge engineering. So what we're working on is methods and techniques to elicit knowledge from experts, from data, and represent it in formal logics-based structures such as ontologies and knowledge graphs, right? And these are very important structures to capture knowledge. Therefore, my question to Michael earlier on, right? So this field has been going on for several decades, right? From even the 50s and so on in knowledge representation and reasoning. And the biggest impact that we had was obviously the advent of machine learning and in particular generative AI. So with the ChatGPT being released, we really had an existential crisis as a field, right? So we had to ask, are we still relevant, right? Are we still needed? Will ChatGPT just replace us? And I think this was very important, right, to have this existential crisis, and it was doom and gloom for 2 years. But eventually, we did something very important, what also Michael mentioned. We took the time to look at these technologies, to experiment with them, to understand what they can do, what they cannot do. So I think this is an important thing that scientists should do right before they do rash decisions, and really found what are still strengths in our field. So I think this kind of led to a renaissance in our field, and paradoxically, we found that Gen AI will not destroy us, but makes us stronger, right? Because it helps to extract knowledge much faster, but at the same time, this structured knowledge that is approved helps in tasks such as fighting hallucinations, for example, right? So that was great. So that's, let's say, the biggest impact. In a way, it reshaped the community where I come from and gave us a new sense of purpose and how we can live together with this technology, how we can reshape our research agenda. The other point was also linking a little bit to what Claudia said, because of the widespread use of AI in various disciplines and the impact on society, it's not possible to ignore anymore this impact, right? And we are very unprepared, let's say, just coming from computer science education to deal with this. So there's been an increased need to work with colleagues from social sciences, philosophy, communication science, ethics, and so on to really make sure that we use our technologies in an ethical way. So I think these would be two key impacts so far.
Okay, thank you very much for sharing this. In particular, so this with the existential crisis. So this is not something people like to talk about, but certainly this made people in the area of symbolic AI think. Well, thank you very much. Then, let's move on to the next question. Hopefully this works. Yeah. So this is now we are talking about the future and what can we expect where AI will develop to, so to say. Of course, it's very difficult to make statements about the future, so in particular if it's the future itself, but what is your idea, so to say, or what can you think of in particular? Can you think of something which would be the next big thing that we can expect in AI? And I hate to have it like in school that we have to go always in the same order. So he who or she who wants to pick up this question first, please go ahead.
All right, I'll start.
Okay, Pascal.
I'll start. So I was meeting with the dean of Johns Hopkins about a few months ago, and he was telling me, so do you ask an engineer if he works with mathematics? And obviously the question is absolutely no, nobody asked that, right? So it's obvious. Mm-hmm. And so he was telling me, but in 5 years' time, nobody will ask, any engineer if they are working with AI. It's going to be obvious. So I think it's going to transform every aspect of engineering and the aspect of science. I think we don't really know how. I think, I know some of the things in my space. I think one of the big things that we are looking at now is design. So this is very different from some of the operational problems that I talked about. But I think, the design in engineering is still something that people think is very human. But I think with the technique, with AI, I think we will be able to speed up that design in very similar things that you have seen for medicine and drug design as well, but in engineering design. And I think the one thing which I believe is going to be interesting is that we will have to combine some of the tools that engineers are already using in terms of the way they model some of the engineering artifacts that they built with some of the machine learning. And I think that's what you're going to see in the next couple of years. But again, I don't have a crystal ball, and as Michael has said, 5 years from 5 years ago, I would not be talking about any of the things that I've talked about today, right? So.
Okay, thank you very much. Now, who is next? No?
Yes. So I believe that there's a current trend for increased attention to scientific machine learning in the whole community of AI. You can see this also in the submissions to the top-level conferences like AAAI, that this topic is rising. And I guess we will see some more breakthroughs out of this. And I hope, and I also currently see that AI researchers more engage towards important, serious problems, because it's not so important to generate a high-quality video of a ballet dancer who is dancing with a white cat on the head. That's very realistic. It's nice for the company of OpenAI, but still I believe that's not really your major challenge you want to solve. And I see that there's much more interdisciplinary attraction to AI topics, and also core AI researchers are taking care of more such serious problems like managing the disease progression of patients with Alzheimer's disease, for instance, which is really something where we still need more research on. And I believe this is a nice thing to see, but still I'm also not so optimistic, because most of the money spent currently in AI research research is either going into the military direction or in making profit out of AI. So I hope that we will have more development of AI technology for social good.
Maybe I can go next. So I think in terms of making predictions on the methods, it's probably an ingrateful job because you will be almost certainly wrong. Nowadays we use methods that were invented less than 10 years ago, right? So all the generative models are, even though the principles exist longer, are probably maximum 5 years old. So, but I would like to probably think at least what I consider will be important milestones, and we are likely to see them. So probably in scientific discovery, breakthrough probably will come first in formal fields like mathematics, so prove some important result, either with the help of AI or totally autonomously. Probably major scientific discovery in the physical or life sciences, potentially also an engineering or design application, so it could be a new drug, for example, or a new molecule that is difficult to design by hand. Could be a new material, so for example, room temperature superconductors, one of the holy grails, right? Or maybe new materials for carbon capture. So there are actually several startups and several labs that are working on this. So this might happen on the horizon of 5 years, maybe not as a commercial product, but at least as a prototype that has never been seen before. Applications outside of these domains, so we already see it now. So basically entire industries are completely revamped. So one of my colleagues is vice president at Amazon, so they produce their movies. So he's saying that what required maybe a few weeks or a month and with human actors and a very complicated set, now almost more or less with off-the-shelf commercial models can be done orders of magnitude cheaper and faster. So there are some issues with how to control at a very fine-grained these models, how much is also achieved by post-production, how to ensure continuity across different shots, but bottom line, this will probably be happening. So all that has to do with creative industries, design, movies, music as well. So I remember I had this discussion, I had a colleague at Harvard who was both a musician, a composer, and also computer scientist that was working on music composition, and that was around 2018. She was saying that she doesn't believe that in her career or maybe lifetime she will see any interesting music composed by computer. Nowadays we can argue whether it's interesting or not, but we have programs that compose out with a waveform, basically music with words, with lyrics, everything basically just as raw data. So whether there is some kind of spark of genius that makes Beethoven a very special composer, I have a cynical, unfortunately, opinion on this. We can probably do way better. We can actually measure the emotional response of humans, and I think there is also research in Austria that somebody, I forgot the name, is studying this. You can optimize the music to elicit a very particular response that probably would be impossible by any human composer. So you can optimize it to death, as artificial intelligence is probably capable of doing. And we'll be seeing progress also on this that was considered to be really the last bastion of human creativity and the soul, or whatever these amorphous terms that you can try to use. So I think we will probably see something like this as well. Whether it will be in the next 5 years or 10 years, hard to predict, but I think it will inevitably come.
You are scaring everyone.
Well, I think it's just the next step in the evolution of humans. We'll
Thank you very much. No? So, Marta, no? What's your take?
Yes, I will take a much more short-term vision, right? So as my distinct panelists said, it's very hard to foresee what will happen. Actually, I want to tell you a little bit more about what we are doing in the bilateral AI project, which is co-sponsoring this event, right? So I think it's rightful that we say a few words about it. And in this project, the focus is on developing new AI techniques that combine both symbolic and sub-symbolic techniques, right? So Pascal already told a little bit about what this means in the optimization field, right? So combining optimization methods with machine learning. In BLI, we have a little bit of a different flavor of neurosymbolic systems, in particularly looking at logics-based systems, ontologies, knowledge graphs, and how we combine them with machine learning models, large language models. So why is this exciting? Why is this useful? So I think there's three motivations to do this. So first, we've seen through the day, right, how disciplines can learn from each other in terms of metaphors. And one of the metaphors that stays behind the neurosymbolic vision is Kahneman's think fast and think slow theory of decision-making of humans, right? So I think it's quite exciting to take that as a motivation and see whether we can take slow systems like knowledge-based systems, right, that take some time to reason and so on, and combine them with fast, intuitive machine learning models, how we can do this. So there's this cognitive science motivation and really just testing a hypothesis and a theory from another field in computer science. Then there's also a theoretical motivation because we've seen that these techniques have complementary strengths and weaknesses, right? So why not try to combine them synergetically and see where they can help? So for example, can we use ontologies, knowledge graphs that have terms which domain experts understand to better explain the results of machine learning models? And last but not least, coming actually to something what Pascal mentioned in the morning as well, the application areas out there are changing a lot, right? So what we see, there's a lot of data, a lot of multimodal data that we need to manage. And here you need machine learning, yeah, you cannot get around it. But at the same time, in complex domains such as smart grids, for example, but also medicine and so on, but mostly in engineering areas, there's also a whole lot of knowledge about the domain, right? So, for example, causal knowledge, right? This is very hard to learn still for machine learning models. So here I think we still need explicitly represented knowledge and rules to combine with what we learn from the data. So we see all these complex applications that lend themselves kind of naturally to this combination. So I think before we go to the next really 5+ year major breakthroughs, it would be also nice to understand what we can do with what we have now and address these applications that are there. So for me, I think this is one interesting space to watch in the next few years, and would also love to learn what operations research will learn from this neurosymbolic combination on your side.
Can I add maybe one? Sorry.
Sure.
Go ahead.
I just wanted, well, because Claudia, I think you mentioned military applications, so it's interesting that just a few years ago it was completely taboo. I've been recently, just a few weeks ago, in a EU meeting, and everybody is talking about it. I think the war in Ukraine has changed everything, and then probably also the change in the US administration and the perception of that Europe also needs to basically be back on the military map. And I think the use of AI is probably inevitable in this field, at least in defense. So I'm also seeing a lot of startup companies that come and be funded, and it's probably one of the most prolific areas of research now. Also, the fact that the warfare itself changes, and drones now become one of the primary weapon platforms. So we'll probably see progress, and we already see the use. It's probably not well known to the public, but we'll probably see it increasingly more in the battlefields of the present and of the future in the next years.
So, yeah, let me talk about something which is maybe a bit nicer. So I had two things happen to me in the last month. So the first one is my son is writing novels. And so he was born and raised in the US, so he speaks English as the primary language, but he also speaks, other language because we come from Belgium. And so he wanted the novel that he's writing to be read by my parents. And so my parents don't speak English, they speak French, so he took this 250 pages long and used ChatGPT to translate them. And the result was very, very interesting. And one of the things that it was very interesting for is that it's amazing. It's amazing, the translation on many different things. But then when you think about it, you step back, you said, a human would never write that. And it's because there are a lot of inconsistencies in between different parts of the book. And I never realized how bad this would be, but the tenses are changing, the gender sometimes changes. There are all kinds of bizarre things, and you were talking about this temporal and this consistency notion. So we still have a lot of progress. I mean, it works very well for short things and so on, but when you look at an entire book and the way you build the characters, the way you build the story itself, there are a lot of semantic things that we know and we find natural that are not captured. So I think we still have a lot of work and to do, and I think for me, my sense is that it's going to require more than statistical machine learning. It's going to require some really deep understanding of what the text is all about. I don't know. And again, we don't have a crystal ball. It's amazing what you can do just with statistics. But I think there will be progress that has to be happening in the level of consistency and when you are writing. So the second thing that I wanted to say is I was part of a panel in Australia on the future of AI, and after I was on that panel, there was another panel about law, and one of the speakers, Svitolina, this morning talked about the fact that she was hiring somebody who had training in law. And as you know, the law profession is going to change completely. I mean, a lot of the paralegals are going to disappear. A lot of low-level lawyers are going to disappear. There will be a very big change. And so I was expecting that panel to talk about this. But what they talked about was completely different things. They said the way we write the law actually doesn't have to be necessarily written for AI. It just applies very well. And they were looking at what they were doing in Australia and saying, if we remove AI for the sentence, it actually makes sense. And then they also talked about fairness and biases and so on. And they were complaining that the computer scientists were developing technology on biases and fairness that had absolutely no connection with what the law profession wanted to have. And so one of the things that I would like to reinforce is that I think a lot of and this is what Svitolina, if I get the name correctly, was saying, a lot of the nice things that are going to happen in the next 5 years is going to be this collaboration between people with domain expertise and people with AI expertise. And by building these teams, I think you're going to get something that you would not get otherwise.
Can I add just one comment? Sorry for hijacking the discussion, but the translation argument is very interesting. So I have been challenging for already a couple of years all these LLM models with the problem of translating poetry. So poetry is very difficult because if you want to preserve the rhyme and preserve the meter, it imposes a lot of constraints. And so far, it never worked well. So Gemini 3 is the first time when I'm happy, so I asked it to translate, Goethe into Russian criminal slang. And it works very well. It is really amazing. So it also suggests rhymes and suggests terms and explains why it used this particular word and how it fits into the overall meaning and the style and the intention of the original. So truly remarkable.
Okay, thank you very much for sharing your insight. I mean, let's come to the next question. We already briefly, let's see whether this works. Yeah. The science perspective, to some extent, Michael already was talking about that. Now, how will AI change scientific research? It does. So as we already see, so I mean, just as an addition. So I mean, now it's not only that there are things generated, it's also evaluating things. For example, at the major AI conference, AAAI was this year running, so to say, as a standby and large language model-driven reviewing so of text, so to make recommendations about papers, etc. Now I just want to know a bit more about your expectations of how this will shape the future of research, scientific research. So who goes first? I
can start.
Okay.
So I think maybe 2 points here. So one is my perspective as a user, and another one is perspective of one who works on these methods. So as a user, I think, as you already mentioned, so in a lot of everyday tasks that we do are not science. So it's writing grants and reviewing papers and writing, I don't know, this letter or that letter. So these can be automated. We already see that it's, so I often pass my own papers through LLM to see whether there are some weak spots or how it can be criticized, or then look at the reviews that were written and see how to respond to them. In general, when you do science, you often need a discussion partner. So an LLM maybe will not prove a theorem for you, but it will critically analyze your derivations, and it already works very well, so for everyday use. Now, the scientific discovery itself, so what I was also discussing in the talk, I don't think that it will make humans obsolete, and here the metaphor I have is from the way that we design software. So when the first computers appeared, they were programmed in binary code, right? It was very difficult to do. And then in the 50s, probably early 60s, first assembly language appeared. So you already would not write in binary code, you will write into something that looks like language, but it was very conscious of the specific hardware. So you literally had to program with moving data from register to register. Then came imperative languages. Then came object-oriented languages, which already looked more or less like we think of systems and objects. Nowadays, we have vibe coding, right? So you can write your description of a task in human language and then maybe provide a few examples and do a few iterations. So none of these stages made humans obsolete. So it was just moving to a different level of abstraction. So probably something like this will happen in science. So we'll become more productive. Maybe some of the boring jobs will be replaced by AI, or maybe AI combined with some kind of lab automation. So robots will be doing, I don't know, the pipetting in biological experiments, and we'll have more time of thinking of higher level problems and designs, which probably require different ways we train scientists. Maybe some of the jobs that we have now, right, the analogy of the paralegals in the scientific domain might disappear or be repurposed, but I don't think that scientists will disappear anytime soon.
Okay, no? Claudia?
Maybe I can add on this. I fully agree to everything being said, and I also believe that this will be the era for interdisciplinary collaboration, and I think we can improve a lot in this. Still, it's quite difficult as a computer scientist to work with domain experts, because typically they have little knowledge about the foundational concepts of machine learning and AI. So in biomedicine, it's a bit better than in other disciplines like in languages or also archaeology. I'm also collaborating with people from archaeology. They are working with a lot of findings. They are digging out some glass beads out of the soil. And for instance, it's very easy as an easy computer vision task when you have an image of many of these findings, just to separate the individual ones. And this would speed up a lot of their time. And actually we are collaborating with them by students project, because students can do this as practical work in practical courses to help them actually. But I know that it is a difficult challenge to sit together to find a common language, and this will probably modify the training of all scientists, that it would be very good if they would have at least a basic knowledge on these kind of topics, because there's still a separation in, also it's a bit gender driven, that there are some people, mostly females, that don't want to know anything about machine learning and mathematics, and they want to go, for instance, to archaeology research, and there are other machine learning developers, and this kind of separation is still kind of strong, and it will need to be overcome. Yeah.
So maybe I just take over from Claudia, and it's very hard after such an interesting talk to add still to this topic, right? But I want to take your point about this multidisciplinarity, right? Also, Pascal, you mentioned. So I think this is possibly something that will change most in science, and kind of this was the impact by AI, right? The need to sit together with colleagues from other sciences, especially from social sciences, and look at the impact of AI on society and environment and so on in a more broad perspective. So I think this might also change how we educate our PhD students of the future, right? Instead of just giving them the theoretical basis of their own discipline, to broaden their horizon, to teach them how to talk to other disciplines, how to use methods from different disciplines, and so on, so that they can address these more complex problems. And I have very good news. Actually, we started this already. So we have a doctoral college on digital humanism. You see the very nice flyer over there. So this is a doctoral college between 3 universities that actually brings together about 30 faculty across computer science and social sciences, and we are educating a first batch of 10 PhD students that are there to perform a very interdisciplinary projects, right? So for example, you mentioned this idea of trust and fairness, right? And that computer scientists have a very skewed understanding of what these concepts mean. Meanwhile, fields such as ethics or philosophy or law have investigated these topics for several decades. So especially only in this doctoral college, we have 2 individual PhD topics that look, for example, at what does trust mean actually, and how can we take principles from philosophy in particular and translate them into guidelines for software engineering, right? Also for fairness, right, especially in voting systems and so on. There's a similar collaboration between political science scientists and computer scientists to really have an understanding what we mean by these terms that have a major impact on the society and implement them properly, right? So I think I would take this view of a more multidisciplinary approach to science.
You're more in the humanities, and maybe.
Yeah, some comments. So one story, and then something that I think is likely to happen. So when my daughter was in college, one day I called her, and she said, "Daddy, I cannot talk to you. I'm in the library." And I was like, "Oh, wow! What books are you looking at?" And then she told me, "Daddy, nobody goes to the library to get books. I'm here to have a quiet time." And so it's very funny. The way we access information is very different. And I think what Michael and Claudia have said is like, we're going to access information in a different fashion. We're going to do research in a very different fashion. There will be many more productivity tools. Now, one of the things that I think is going to happen is that we, as scientists, have had a tendency to become highly specialized. And I think that's going to change. If you look at the great scientists in the past, they knew things about chemistry, about physics, about mathematics. They knew almost everything, and they were doing deep contributions to everyone. If you look at scientists even in the middle of the 20th century, like Richard Feynman, they had fundamental contribution to so many different fields. It's amazing. And so I think what's going to happen is that we're probably going to get back into this kind of Renaissance scientists where we know a little bit about many different topics. When I ask my students, have you taken a class in thermodynamics, or have you taken a class in quantum physics? It's never the case. And I think that's going to be very useful to them when they start applying AI to many different disciplines. And you will need to have at least sufficient background such that you understand what other people are talking about.
Maybe another thing which is very characteristic of human science and probably will need, or I hope it will change in the age of AI. And our science is mostly based on success stories. You never get a job or a promotion or even Nobel Prize for a failed experiment. You never publish a failed experiment, right? So imagine how many scientists are trying to do a thing that somebody tried and failed. In pharma industry, it happens all the time, right? So you don't know what your competitor is working on. Maybe this drug already was tried and it failed. You wouldn't know, right? So negative results are probably the most important kind of data for machine learning. More important than positive. And this, we don't have access for this. So this is never published, never documented, never stored, and this has to change. So if we are to reinvent science with the help of AI, this probably is one thing that needs to change even in the entire scientific culture. So it might not have the form of publications, but somehow these results need to be documented and stored and made available for AI systems to learn from.
Mm-hmm. Okay, thank you very much. No? I mean, time is running. No? So, I mean, we should speed a bit up. No? There's just one question left, and that's more the kind of political, in the end, how to organize research than in the future. No? Because now companies now are taking the lead, more or less. No? So public institutions like universities have less funding in order to propel the research, because it's quite resource intense and it's costly. So how should one react on this? Any thoughts on this? And what can small countries like Austria, Austria is a small island, so to say, no? Swimming in the middle of Europe, now what can Austria do? No? Or on a bigger scale, what can the European Union do? You're laughing, no?
I volunteer to start again. So, okay, so when we talk about resources, right? So probably the most one thing that people compare, right? So you say whether you're GPU rich or GPU poor, right? So how many basically processors you have that you can run your AI on. So I would like to make a claim that at least in our field, a lot of things do not require thousands or tens of thousands of GPUs. A lot of meaningful research can be done with way smaller resources. What you need to have, though, is to use them continuously. So ideally, a situation where every researcher or every PhD student or every postdoc has access to a GPU 24 hours every day. So can run something on these processors continuously. Sometimes it could be not one, maybe two, or maybe 10, but not necessarily hundreds or thousands. And I think our politicians, and well, we had meetings with, for example, EU commissioner, they invest in these projects where you build a gigantic cluster and then you need to write a 20 pages proposal and have it reviewed for half a year to get, I don't know, 100 GPUs, 100,000 GPU hours or something like this. I believe that this model defies the purpose. So ideally what, for example, the politicians should say is that, let's say, every EU funding or every ERC grant should come with computational resources for every person that is hired on this. At least one H100 GPU should be guaranteed. It's not a big deal in terms of cost, but I think it should be built into the funding models that fund research in this field. I think this will make a huge difference. But of course, there are many other things as well.
Thank you.
So let me take this. And I think universities in general are going to be very, very different in 5 years from now, at least in the country where I currently live. The model is not sustainable anymore, and education is going to change completely. I don't see, faculty actually teaching students in big auditorium anymore. I think we have way better ways to actually transmit the information. And hopefully what we can do is a model where mentorship is actually much more important, where you work with small groups of people and you really mentor them, you really spend time with them. So I think during the pandemic, one thing was interesting. I built a studio in my home and I was recording all my classes. And so very high quality video, all kinds of special effects and so on. The student loved it. And what we did, instead of having classes, is breakout rooms, and I was talking to the students, and they loved it. So I think what I want to do, for instance, is actually having the same context in the physical world. You can actually have the video content, which is there, and then you go from breakout room, physical breakout room, from physical breakout room, to actually talk to the students, build this relationship, mentor-mentees relationship. So I think the universities have to be rethinking about how they educate the students in a world where AI and in the technologies in general are going to change completely. The model of science is likely to be very different as well, because as you said, as Michael has said, I think there are tremendous budget in industry. The budget of research at Google is probably larger than the National Science Foundation in the United States. So the data is in industry, it's not in academia anymore in many of the fields. So it's going to have to change. And I also believe that sometimes small teams are the way to go if they explore things that the big tech, for instance, are not going to explore. They explore things that are completely novel outside the path, and they can generate something that is completely novel. But you need a system that is actually allowing researchers to do that, where the pressure for publishing is going to be very different, from incremental research is going to be different, and they can take more risk. So I think we are at a time where I believe academia, universities are going to fundamentally change. And it's not necessarily bad, it's just that it's going to disrupt the system. And we can go back to some things that we were doing really well before, and we'll have to adjust to some of the things where some of the research is going to be done in industry much more than in academia, in some areas. Michael hasn't corrected me yet, so this is good.
No, I agree. I think it will. That's what it will be in the 5 years, or even faster. I think it's debatable, but I think it's inevitable.
What I believe is that we need also to have a different publication culture in AI because it currently comes to its limits. So the big conferences have number of submissions. So AAAI has 30,000 submissions, 20,000 out of them are from China, just to let you know where the research is performed. And at least in my research field, so I'm doing deep clustering. People are still clustering the Mnet stitches, the fashion Mnet bags with and without straps and handles, and also the Cypher 10 or the ImageNet dogs, distinguishing the different breeds of dogs. I think we need to use different open source data sets. We need to have benchmarks. That's also one benchmark track, and many conferences exist. But I think we need to work on real problems with real open data, and hopefully in an environment where we can do this with European values. So I'm actually very happy to be employed at the University of Vienna, where I don't need to orchestrate the next drone swarms, but I can focus on different challenges like deep hierarchical clustering in hyperbolic spaces. So I'm happy to do that, but I know that I have only a tiny budget for doing so. And when it comes to resources, I would say we need competitive conditions for top-level AI researchers, also at the universities, because not everyone is an idealist, and there are also people looking to earn some money, and I hope that we can be competitive. And in Austria, we are, for instance, a bit better than in Germany, as they have the public servant systems and are more restricted in some ways.
So, Marta.
Just to close, of course, I agree with everything that was said. I mean, also in terms of how teaching will change and publication culture, very important challenges ahead. For me, I think, as you say, it's just we will need to understand the different roles universities play along companies, and it's a fact that companies make a lot of research and development, but they also have different KPIs, right? They want to have products that they can sell, so they are driven by this commercial interest. And I think we have to maybe take a step back and understand what drives us, right? What do we want to do? Do we also just want in this league to have more competitive technologies? Probably some of us, yes. But maybe we can also play this other role of understanding these technologies, right? Experimenting with them. I guess companies don't maybe have the time and interest to have year-long, methodologically run systematic experiments to understand all facets of these technologies, what they are good for, which problems they solve, what are their shortcomings, and so on. So I think we have still a very important role to generate this knowledge and to really understand the pros and cons of this technology. So I think this understanding of technology in methodological ways remains an important mission for universities. And I would still like to add another aspect related to being allowed to fail, right? So as Michael said, this is kind of a topic not many people talk about, but actually in some of our conferences we had some tracks of negative results that were very inspiring actually, and we learned a lot from them. And this should be possible in universities, right? We need to fail to reach paradigm shifts. Right? And I think these paradigm shifts could come exactly from this freedom to experiment and to fail and to reason, as you say, right? So to be free in your investigation. So these two points I would see still as a mission of universities.
Sure, Pascal.
Yeah, there is one thing that I would like to add is that there are two things that universities have to do and have traditionally done, and that we need to go back to. One of them is actually informing the public, and not only the students, but the overall public. So we have to actually explain these technologies to people such that they really understand the strength and the weaknesses, show the magic, but also show the limitations. And I think it's also teaching, it's not only teaching the students, it's teaching their parents, it's teaching politicians and so on. And I think it's very important that we do that at a time where the technologies is so difficult to understand and looks so magical to people using it. So that's number one. And I think the second thing is that I think academics, across history had always a very significant role in public policy, in informing where society was going and explain these things. And I think these days, most academics are extremely careful, to say the least, to actually speak in public, to express ideas in public. And I think at some point we need to go back to that, because the technology is so powerful that most people don't understand what it does. And so I think it's, I would say that universities just to think in those terms and try to influence policies, influence public policies in general.
I think this relates to the demystification point that Professor Kappel brought in the morning, right? So I completely agree, we are maybe shy to go too much in the public eye, but at the same time there's many people that have maybe not so much idea about AI, and they are very vocal about potential impacts that are maybe imagined in many cases, which doesn't make any favor to our field.
If I can add to this, I think it's important, but I think the way that this is done is also very important. And we've seen some probably disastrous examples during COVID. So I think the role of the scientists is to provide objective information rather than to say what to do. Otherwise it becomes activism and not scholarship. And unfortunately we see, even in our field, which somehow scientific field is not supposed to be, activism rather than scholarship, and this is very antithesis to the essence of science that could be. It's not that scientists are not humans and do not have opinions, but they should keep them separate from their scientific exploration. This is my opinion.
Well, thank you all very much. No, I mean, for sharing your opinions. I mean, actually, time is flying like an arrow. No? So, I mean, we are almost at the end. But, I mean, we still may ask the audience if there are some questions that you have to the panel.
Do you think that the advances in AI will also have an influence how data in the future will be shared? So either within the scientific community, but also public data, because maybe the value of data gets more and more valuable?
I was talking about that at lunchtime, I think. I think there are a lot of advantages in actually putting your data out there. But I think, once again, you have to build a social net to actually make sure that it's actually used in a proper fashion. So I think that's, I think Michael has mentioned the role of data, which is super important and is going to drive, everything that AI can do. At the same time, if everybody is putting their own DNAs and everything else, on the, publicly, or, even to the government, I think, at least in the US, the insurance companies could actually do different kinds of rates for different people. So as a society, we'll have to decide, do we want that? Are we putting, kind of guardrails and so on? So I think this is a very interesting and very difficult topic. And I'm sure Michael is going to comment on this in a second.
Of course, I will. So if you think of it, data, let's say user data, right? So if just I give my data, it is not very meaningful, right? So quantity is the new quality for machine learning, and data makes only sense when it reaches a certain threshold. And for different problems it might be different, but basically it's the vast amounts that make it useful and precious and special. So on the legal side, there are many interesting challenges. So in the US there was this famous ruling, so Google was sued for using copyrighted material to train their machine learning systems, and the ruling was that discriminative AI systems do not violate copyright because you cannot recover back the information. So if, for example, I don't know, you train your spam filter in Gmail based on text from books that Google stores and indexes, this is not a problem. So generative models, which at that time were not interesting or powerful, that was almost 10 years back, were explicitly left out. Nowadays we have generative models, and this question is reopened, and I think it's the jury is still discussing, so it's not clear. It might completely change the way that the field works. So if the ruling will be that it is actually violating copyright laws, then the results potentially will be catastrophic for companies like OpenAI and so on. So the law might need to change. What you see, for example, in pharma industry. So there is a lot of data that is very sensitive, very expensive. So the companies would benefit from pooling this data and allowing machine learning models to train on it. The problem that it's when lawyers come ahead of researchers, the upside is dubious, the downside is catastrophic, right? So if your new drug leaks out because you shared it with your competitors, then the downside, right, could be multi-billion damages. So we need to change the mindset. We need also probably, and there exist algorithms, so federated learning, some cryptographic tools like homomorphic encryption that allow actually to do machine learning on sensitive data without exposing the data. So I believe that these technologies need to be adopted and eventually will probably be adopted to make the sharing of data useful for everyone.
Thank you very much. So further questions? There are questions. So let's.
Yeah, thank you very much for a very interesting discussion. So maybe I will just come back to the fourth question again about the role of the universities in the future. So what would you recommend that the universities just concentrate in basic research? They try to transfer results as much as possible to industry? Or, yeah, where do you see the best possibilities for the university?
Should I try first? So again, it's hard to say because I think this technology is very quickly upon us and probably it will be bigger change than anything else that happened in our history. But if you look at analogies, right? So the way that we taught at school, so for example, when I was studying history, so we're made memorize all the dates of battles and then some historical events. With the advent of search engines, there is no need for this, right? So I can Google immediately when the Battle of Crécy happened, right? Or something like this. So teachers also had to change their mindset, and basically the learning moved more into meta-learning, so learning how to learn rather than learning that particular discipline. So probably something like this, but on a bigger scale, will need to happen with when AI tools are widely used. So probably will not be, if you ask a student to write an essay in English, GPT can do it, ChatGPT can do it better than anyone. So it's probably not the outcome that we should be testing, but the way that the student uses these tools to produce this outcome. So I would be probably looking at the interaction trace rather than the final result, or maybe not only looking at the final result. So it will become a tool, but it will be a tool that is not only like a calculator that amplifies mechanically the brain, but it's part of the creative process. So basically, back to your question, I would say that it is learning to learn that will still remain an important ability, rather than that particular domain knowledge. And yeah, you will still probably need to have it, but probably on a less detailed way. And I totally agree with that. We'll probably need to go back to being Renaissance people in the future.
Was your question about whether we should focus on basic research or applied research?
Yeah, more about research, yes.
Okay, yeah. So I think both. I think basic research remains very important, and especially understanding fundamentals and theories, and I think this is exactly what we should give further to future students, whether in a Renaissance methodology or another more recent methodology. As we discussed, right, AI will take over many tasks, right, many mundane tasks, but what remains still very important is that people understand the fundamentals, right? So I think also the next generations of students that will go to work in these big companies, they should bring these skills with them, right? They shouldn't just be able to blindly use AI tools and take for good whatever they produce, but they should understand the principles and the mechanisms behind. So I think we need to be the bastions of basic research and basic knowledge, and giving this further to other generations. At the same time, I think it doesn't hurt if we try to also take these results and try to see how they can be translated into innovations, especially the step from basic research to first applications is quite quite a big gap, right? So once you translated some basic fundamental theorems into something that works, a prototype, then you can take this and build a commercial product. But going to this minimal viable product, I think it's very, very difficult, and I don't think that can happen only in industry or only in university. I think there's a sweet spot there where universities need to work together with industries to do this transfer, at least into a first prototype.
Can I add maybe one point? And well, if you ask, slightly tangential but related to your question, so if you ask what I am afraid of with AI, so it's not some kind of extinction scenarios or Skynet or all these sort of things. I'm more afraid of the loss of skills. How many computer scientists can build a computer? How many people here understand actually how a computer works at the very basic level of hardware, right? So I cannot raise the hand because, well, I studied it at some point, but I don't remember it at all, right? So, and this happened throughout our history. So skills that were essential for the survival of civilization became, with technology, became redundant and were lost. How many people here can ride a horse? Right.
Ride a horse.
Exactly. How very few, right? So, and this just a few hundred of years ago, that was people would literally live or die based on this capability. So, if we outsource our mental, creative, cognitive capabilities to the machine, that nowadays, at least, we have no idea how it works, we might end up in this kind of situation where things happen magically on our behalf, but we have no control and no understanding of what is going on. So I'm basically the dystopian scenario that I'm afraid of with the use of AI is this.
Yeah, I think this is very interesting. So as Thomas has said, I'm a very old person here, and so I actually coded in assembly in my second year of college, and I think and then I taught computer architecture, and I think what is the beauty of this is that you actually can see through the layers. And you understand at the deep level everything that you write at the very high level, what is happening in the machine. And these days, I think, there was something interesting that you probably said about the technology, and you are, somewhat driven by the way the hardware is working. And so I think it's very important that students are actually, and that we actually as faculty, we teach, to see all these layers. I also think that this is a very unique skills of computer scientists. And then when you move to another discipline, you are always coming with an idea of what are the abstractions. And if we lose that, we are losing something which is very unique and which bring computer scientists to actually look at other areas in very different fashion. And I think that's one of the things that, as computer scientists, professor or, practitioners, we should keep reinforcing this concept of abstraction, the ability to see through the layers. And when I see some of my students now, they code everything in Python, they start in Python, they have absolutely no idea what is actually happening behind the scene, except the very top students who are still interested in actually looking at what is the code which is generated in the latest version of Python, right? But this is what I think is really important.
So I want to say that AI is really an intersection technology which touches or connects computer scientists to so many other fields. And this, I think, is really amazing. And I enjoy to work with people from very different backgrounds. And sometimes I'm really inspired by their knowledge. This gives me also, enhances my own creativity to see problems from a different angle, because there are people, they are doing more qualitative research than quantitative research. It's about line of arguments, about summarizing highly complex interactions between crowds of people, things like that. And that can really be inspiring. Also, when you are working in the area that you yourself are designing clustering algorithms, you can let yourself inspire from phenomena like synchronization. Then you can look for mathematical models, how to model this, and this might be a new angle to problems you are working in. And when AI is kind of the glue which connects us more to other people, then I see this as a very great chance. And also I see it as connecting more people to more technical disciplines who tend to stay away from those, maybe also due to gender stereotypes and other historic reasons. Hopefully these people feel more encouraged to enter also more technical. So I think the borders between disciplines could be a bit vanishing, and that would be great.
Thank you. No? I'm not sure how we are doing in time, no? Because I'm looking at Newsed, no? So because I heard that they will throw us out at a certain point in time. If this is not the case, then I think Felix had a question, right? So.
So I was wondering, sometimes I hear from people concerns about the electrical power usage with the AI methods, especially with large language models. And there are people who are actually concerned that right now it costs a lot of energy, essentially, for the big large language models to work, and maybe AI in general. And that some people also mention concerns that there might be even an investment bubble, that now companies are funding this power and so on, and that this bubble might break at some point. And I was wondering, what do you think about this, about the power usage with the AI methods? I mean, I think you touched this already in a way that you said with AlphaFold, it's not only about this mass number of GPUs and this big data, but I was wondering, do you think what will happen in the future with this electrical usage of AI? And is it still a requirement? Will it be a problem? Also from an environmental perspective, maybe?
Again, I will volunteer to try to answer. So I think the short answer is probably nobody knows, right? So there is this kind of sort of inverse Moore's law. So I think Dario Amodei had a blog post about it, so that if the first AlphaFold took something like 100 TPUs to train on at Google, then the subsequent versions reduced it by probably an order of magnitude, with the same algorithm and the same capability, so just basically making some tweaks and improving algorithmic efficiency. We've recently seen this this year with DeepSeek, right? So you can of course argue about whether it was orders of magnitude or just a couple of times cheaper, right? So depending how the numbers were reported, but I think it's not a surprising thing, it's rather a trend, right? That again, estimates vary, but probably every year it's between twofold up to an order of magnitude, basically algorithmic efficiency. Of course, at the same time, models tend to be bigger and the amounts of data tend to be vaster, and but also at the same time, GPUs become more efficient. So basically, there are these contrasting trends. I've seen recently an estimate that the US is missing something like a scale of 100 nuclear power plants to power the data centers. So probably this is at least currently the most efficient energy source that we have, with all, of course, the downsides and potential risks. But I believe that politically this is also the change in the narrative and the government policy. So in the UK, for example, there is probably change in the way that portable nuclear reactors are becoming a new trend. So regulation probably will make it possible to build and to deploy. And I believe this will happen in other countries as well. So yeah, energy consumption is a big issue, and it will probably continue to be.
So let me take an engineering answer here on complementing the more computer science part. So I think you can. First, it's not only electricity; it's water. I think water may be even a bigger problem at this point than electricity. The electricity, I think you just have to build microgrids. So you have to build every data center should have massive solar energy, massive wind, and massive batteries if you want. To make sure that the effect is not significant. In the US, I think the electricity bills in a number of states are starting to increase because of the data center. So the public is going to is going to start seeing the effects, and when the public sees the effect, since there are elections, you will see some counterbalance at some point. And so I hope that they will actually start thinking more creatively in terms of how you actually have a much more reasonable use of energy, building about renewable energy, which is completely, underutilized at this particular point in time. So that's what I would say. I think there will be also, the way you operate these very large data centers, the way you manage the load, all these things is also going to improve at some particular point.
I think we will also learn for which kind of problems we really need deep neural networks and for which other classes of problems we don't. So it's not only about reuniting the symbolic and the sub-symbolic AI, but also there are some old school algebraic spectral methods which are often remarkably competitive to very strong, deep AI methods at a very minor energy consumption level. And this will, I think, continue, and we will have hybrid methods. Also, when you think about all these Chinese authors submitting papers to AAAI, many of them don't have their own GPU, and they are creative with little resources and get the papers accepted. So therefore, you see that this development also comes. So often it's just a restriction to compute resources where you need to cleverly select a topic where you can still get in.
Can I maybe add just one thing about the development of the algorithms and the hardware as well? So if a couple of years ago, right, so ChatGPT appeared exactly 3 years ago now, the initial generation of these AI models were monolithic big things, right, that you train it once with huge investment on I don't know how many thousands of GPUs, right, consuming whatever megawatts of energy, and then you deploy it and it knows what it was shown at the time of learning, right? Nowadays, the trend is that basically breaking up these monolithic models into smaller models that you can fine-tune, that you can deploy on the edge, so scaling in inference time. GPUs are also optimized for this. So basically you're pushing the heavy lifting to the devices that you have in your pocket, like your smartphone. And therefore you also distribute the energy consumption rather than a single concentrated data center across the globe.
Yes, so thank you for the question. I think this is very important. Undoubtedly, we have to be aware of the environmental impact of AI, but also of technology in general. And I think this is very much in the focus of the scientific community. My colleagues already gave some ideas of, optimizing these infrastructures. In fact, in Austria, we have a call AI for green, right? And green for AI. So kind of how we build sustainable technologies. But I think we have to also understand that this is a very complex problem, right? So it's kind of giving a simple answer to very complex problems, saying that AI is now the scapegoat for all these issues, right? There's much more there. The water is a main problem. And I've just seen actually a presentation by colleagues at WU who look at sustainability aspects of technology, and it's amazing. I mean, it's the whole supply chain, right? So let's don't forget the whole steps that are there to produce all the electronics and the servers and so on. And actually the training and the usage are 10–20%, right? So it's much more, and we could do much more by reducing consumerism, being more aware of our, scrolling through phones endlessly and so on. So I think there's different ways to attack this. It's an extremely complex problem, and I think it's a little bit of shame that we only look at it now because of the AI models. We've been having this for a long time, right? Data centers have been there ever since you use Google Docs and, Gmail and so on, and this trend has been going on. Nobody really raised the issue until now. I agree we have to look at it, but we have to look at it in a more nuanced way and really to understand what is exactly what we can change in AI and what are also other things we can do to reduce this impact.
Thank you. Well then, now, there is still one question, but maybe the last one, because we are quite over time. On the other hand, it's nice so to see people discussing.
As experts in the field of AI, what recommendations do you have like for making the development of AI ethical and sustainable without causing much harm to the society and to the earth as a whole?
My answer would be to have a multidisciplinary approach and involve a lot of disciplines, in particular social scientists. So this is what we do in our doctoral college, as we mentioned, and for us, this is our best guess so far what we can do.
It's also a matter of funding, from where the money comes. So usually the funding bodies gives also the goals for what you want to do with the funding. So when we have public funding, then, for instance, from the European Union, we can develop AI methodology with the European standards or European values. That's very good. But of course, when you have other funding sources, you know, who gives the money also. In terms of research, I think we also need more diversity. We need diverse participation of all genders and all regions as far as this is possible, and also some fairness, methods for fairness and privacy preserving AI. So a lot of answers in short.
Well, if I have something to add to what has already been said, so in my view, it's not AI itself that should be regulated, but its applications. And same thing, you can argue that, right, nuclear physics, you can use it to build nuclear power plants or nuclear bombs. So it's the application that matters, and the consideration should be there primarily, rather than with the algorithms and the systems themselves.
So one of the things that I'm thinking about all the time is that this is a very powerful technology. And compared to other fields, you know, the training in ethics and sustainability, all this social aspect is extremely weak. Most of the students who I have don't have actually an ethics class, or they can, you know, just bypass the ethics requirement and take a history class. I'm not saying that history is bad, right? So, I mean, it's super interesting. But the fact is that they may not have, and everybody should learn about history, but the fact that you don't necessarily, you can go through a kind of an entire education without having an ethics class is kind of mind-boggling given the power of this technology, right? So obviously every medical student has to go to a significant ethics class, and I can tell you, you know, this is super hard. It's not easy at all. And so I wonder why, you know, we are so late in actually putting that in the curriculum. I'm not talking about Austria here. I'm talking about the schools that I know of. And so why we are so late in actually giving our students the frameworks, the kind of the mental models to think about ethics in the context of something as sophisticated as AI. And so I think, you know, we need really to rethink about this and what it means, and not in a negative way, right? So in medicine, you know, nobody sees ethics as in a bad fashion. It's something that you just do because you have to understand the dilemmas that you have to go through. And I think every computer scientist, every engineer using AI should think about those. What are the dilemmas that I'm trying to arbitrate at a particular point in time?
Thank you very much. No? Okay, I think it's time now to close this panel. No? Let's thank the panelists for their availability and for their sharing their experience and the vivid discussion. And thanks to the audience for staying, because there's still a lot of people here and nobody fell asleep. No? Have a nice evening. No?